Hello, everyone. Welcome to Math with Ruth. So today I just got back from a Christmas party / work meeting, so that's why it's going very late. Anyhow, I'm just going to get right to the point and start with this mumbo jumbo. And I hope you like the little Christmas music that I just put in the beginning. Very weird. I know. It's all right. Anywho, we are going to get this started. And there you go. Putting it from the very beginning. So it says Chapter 6, Fractions and Rational Numbers. So the first thing we see is problem number 1. It says pattern blocks are a popular and versatile manipulative that is used successfully in many elementary school classrooms. The 4 shapes below are included in any set. So before we get started, I'm going to put this is the 4 shapes. We have a hexagon, a trapezoid, a triangle, and a rhombus. I think that's how you say it. So the first thing we have to do is write sets of fractions having 3 fractions in each set. Let each pattern block be the base unit for a set of fractions and show a fraction to relate each of the other shapes to the base. So these are going to be the fractions for hexagon, for trapezoid, for triangle, and for the rhombus. As you can see, you will remember these fractions because they are very essential to the next slide. All right, the way we know why we get those fractions is by fitting the other 3 into each one and seeing how many spots it fills. So the very first one is the trapezoid, and we see that it is a whole, 2-hole trapezoid. So therefore, what did we say about this? It is 1/2. So since this one gives us 2 into 1, that is, trapezoid fits into the hexagon twice, making the first fraction a half. So the next one, the triangle, fits into the hexagon 6 times, making the second fraction 1/6. As you can see, all of these are triangles. It's pretty cool how watching them fit into the hexagon 6 times. So therefore, it's 1/6. Next is the hexagon. The rhombus fit into the hexagon. So as you can see, I've already kind of outlined this, and it fits 3 times. Therefore, it is 1/3 because the 1 stands for the hexagon, and the 3 is for the rhombus, how many pieces of that fit into that hexagon. Next one, it's the trapezoid. And as you can see, we continue with the next shape, which is the trapezoid. So the hexagon is 2 full trapezoids. So therefore, the fraction is actually 2 wholes. As you can see, that one fits in there. And then it fits again. I can twist it around, but you can see that both of those shapes are the exact same. Next, it's the triangle fitting into the trapezoid, and it fits 3 times. 1, 2, and 3. Therefore, the trapezoid fit into the triangles fit into the trapezoid 3 times, so the fraction is 1/3. Next is the rhombus. The rhombus only fills the 2 shapes. It only completes 2 of the 3 parts of the trapezoid. Therefore, the fraction is going to be 2/3 because it only shades 2 out of those, as you can see right there, because we have 1, 2, and 3, and this only fills those 2. And so, as you can see, so the next one we do is this one. The hexagon. So as you can see, 6 triangles fit into the hexagon. So the answer is 6 holes. So it's 1, 2, 3, 4, 5, 6 triangles. The next one, it's 3 triangles fit perfectly into the trapezoid. So the answer is 3 holes because it's 1, 2, 3. Now, 2 triangles fit perfectly into the rhombus, so the answer is 2 holes. So as you can see right here, we're using the triangle now. So there's 1 and 2 hole. So they fit both in there. Therefore, it's 2 holes. Next is the rhombus. As you can see here, the rhombus fits into the hexagon 3 times. As you can see here, these are exactly the same. I just didn't make it go in there because it would take too much time. But as you can see, there's 1, 2, 3. So, therefore, it's 3 holes. The trapezoid, since only 2 out of the 3 parts of the trapezoid are fully covered by the rhombus, the fraction is going to be 3 over 2. Like I said before, these are cut into 3 parts. So it's 1, 2, 3. Therefore, the rhombus only fits 2 times in there. Not 2 times, I mean, only covers 2 of those shapes that are cut into it. So therefore, it is 3 over 2. Next, the triangle fits 2 times into the rhombus. So the fraction would be 1 over 2. Because you can see, if you cut this right down the middle right there, it's going to give you 1, 2 triangles. Now, the number 2 is a man body length of rope at a hardware store. He used 1/3 of the rope to make a bow painter, a rope located at the front of the canoe. For this canoe, and then used 1/4 of the remaining piece to tie up a roll of carpet. He now has 36 feet of rope left. What was the length of the rope he originally purchased? So, as you can see, we add a mark on the remaining portion of the rope designated the amount used to tie up the carpet. Since 1/3 of the remaining piece is used to tie up the carpet, the new rope is represented by the picture below, which is right here. As you can see, it's 1/3 here and 1/4 here. Considering that the 2 pieces were 1/3 and 1/4, you multiply 4 times 3, which is 12. Then you add it to 36, which adding them together, 36 plus 12, is going to give you 48 feet. Therefore, that is your answer. Now, this is a little bit more exciting. So we are to represent each of the following function facts with a fraction strip model. So as you can see right here, I actually really, really like these because they kind of help you visualize. So the addition is 1/3 and 1.5. So let's see here. So as you can see, this right here has 1, 2, 3. So it is divided into 3 parts. And only one part of it is highlighted. So that's going to be 1/3 plus 1, 2, 3, 4, with 1 only shaded in, plus 1/4. That in return is going to give you 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I actually got the wrong question. That was supposed to be 1.5. I mean, 1/2, but instead I put 1/4. So my bad. Just pretend this is 4. So we're just going to put that right there. So what is the common factor of 3 and 4? So 3 times 4, you can just multiply it together, and it's going to give you 12. So therefore, there is 12 little slots right here. But now what we have to do is see how many would fit in there. So we put those 2 fractions there. So now we have 12 little ones, and now we see how many are shaded in, up to which one they're shaded in. It's 1, 2, 3, 4, 5, 6, 7. So it's 7 over 12. I don't know why I did that. I am so sorry. The next one is going to be 1 over 2 plus 3 over 4, which I actually did correctly. Good job, Ruth. So as you can see, we have 2 parts, like a bar with only 2 squares or rectangles, whatever they are. And this one right here is the only one shaded in because that represents 1 over 2. And this one's 1, 2, 3, 4, and only 3 are highlighted. So we add those 2 together and we get 1, 2, 3, 4. So it's a full 1. So this is going to be 1. And 1, 2, 3, 4 with 1 shaded in, 1 over 4. So it's going to be 1 and 1/4. And there it is. So the next one you are going to be subtracting. So therefore it's going to be 3/4. 1, 2, 3, 4. And only 3 highlighted. So that represents 3/4. Minus 1, 2, 3, and only 1 highlighted, 1/3. So now, as you can see, this part is right next to each other, and this is how many you're supposed to take away. Therefore, we align them like this, and it gives us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 with only 1, 2, 3, 4, 5 highlighted. So it's going to be 5 over 12. And then we find their sum by dividing the sum of the numerators by the common denominator, and then it gives us a little number line diagram here. So then number 4, it says, represent each of the following fraction function facts, wow, with a fraction circle diagram. So what we did is it's 3 times 1 over 5. So what we're going to do is get 3 1/5 and add them together. So then we have 1 here, 1, 2, 3, 4, 5, with only 1 in is 1/5, plus 1/5, plus 1/5 is going to give us 1, 2, 3, 4, 5, with only 3 shaded in, 3/5. That is going to be our answer, as you can see with the little shapes right here and the number here. Next is 3 times 2 over 4. So that means we are going to grab 3 2/4. So it's 2/4 plus 2/4 plus 2/4. It's going to give us 1 whole and 2 over 4. So you can see that is the answer we got right there. Next one is going to be 5 over 8. So we're going to get, again, 5 over 8. So this is 5 over 8, 5 over 8, 5 eighths, 5 eighths, 5 eighths, because only 5 are shaded in and there's 8 pieces. So whenever we add all these together, it gives us 3 wholes and 1/8, which means 8 pieces and only 1 shaded in. And that is the answer we get right here. Now this one is a little bit more complicated. It says a unit square is partitioned into the 7 tangram pieces, A, B, C, D, E, F, and G. What fraction gives the area of each piece? So before we get to here, we're going to look at these right here. It says you count to see how many shapes there are. So there's 1, 2, 3, 4, 5, 6, 7. You notice that A and B, these two, are the same size. Also, what other shapes are the same size but C and D, as you can see right there? D and F are 2 of C. So D and F, see, if you cut D in half, is going to give you 2 C's, so 2 triangles. And F, if you cut it like this, is going to give you, again, 2 C's. So we know that C and E are the same size. And then this and this have 2 of C. That leaves G, which upon further observation also gives us 2 of C. And I took the liberty of putting the little dotted line right here and cutting it in half. I guess I could have done the same for this, but you can see it. Since A and B are part of the half, so this is cut in half, each are 1/2 because this is 1/2. Each well, as you can see, they are 1/2. So what is 1/2 of 1/2? It is 1/4 square unit. And B is also the same thing, so therefore it is 1/4 again. C and D are 1/16 each. C and D. And how do we know that? Well, if you put these together, you see that there's 1 and 2, 3 and 4. So you pretty much divide 1/2 into 4 parts. And that is going to give you 1/16 each. And the rest are 1/8. And how do we know that? Well, as you can see, D right here is half of C, which is 1/8. So therefore, no, as you can see, C is 1/16 and half of, well, half of 16 is going to give you 8. So as you know, in fractions, the smaller the denominator is, the bigger the shape is. So therefore, it is going to be 1/8. And 1/8 and 1/8. It says, list of ingredients for chocolate brownies given at right will make 16 brownies. So this is supposed to give us 16 brownies. Use the list to decide how much of each ingredient is needed to make 12 brownies. So we only need 12 brownies. So how are we going to cut this down? Well, first you divide each ingredient by 16. But you do desired serving size over serving size given. Then you multiply by ingredient amount in recipe. So pretty much what you're going to do is going to put 3/4 because, well, as he said, the desired serving size is 12 and the serving size given is 16. So you're going to do 12 over 16, which whenever you round it down, is going to give you 3/4. Then you multiply by the ingredient amount in recipe. So the ingredient amount in recipe is actually 1/3 cup of butter. So as you can see, we multiply these two together and it gives us 1/4 cups of butter. We continue doing that the same way. The 12 over 16 rounded down is going to give you 3/4 times 3 ounces of unsweetened chocolate. So multiply this and it is going to give you 2 1/4 ounces of unsweetened chocolate. Next, you do the same thing again, which is 3 over 4. And this time is going to be by 3/4 cups of sugar. So 3/4 times 3/4 is going to give you 3 over 8 cups of sugar. Next is the same thing again, 3/4 times 1.5 teaspoons of vanilla. So whenever you multiply this, it's going to give you 1/8 teaspoon of vanilla. Next is the same thing again, 3/4 times 2 eggs, which whenever you multiply these is going to give you 1.5 eggs. So I don't know what you would do with the other half of the egg, but apparently that is what they want. So good luck with that. So 1 cup of flour, let's see, 3/4 times 2/3 cups of flour multiply together is going to give you 1/2 cup of flour. So that is what you would need to make 12 brownies. And that, my friends, is all. So, I hope you guys found this pretty interesting and you liked it and that you learned something from it. So, good night and see you all next time.